Humankind has, for a very long time, gazed into the interminable gloom of the night sky, filled with wonder about the many unexplained secrets that lie beyond our world's reach. In the 1900s, scientists introduced a theory known as the Big Bang to describe how the universe came into being, how it developed, and why it continues to grow. Despite the fact that this theory became widely supported, it still fails to provide answers to some of the most fundamental questions about the cosmos. In recent times, groundbreaking discoveries have made these mysteries even harder to explain. In 2023, such a moment emerged when the James Webb Space Telescope from NASA detected astronomical objects that appeared to date back further than the universe itself. This revelation stunned scientists and sparked a contentious discussion. Could it really be possible for stars to exist longer than the very universe they reside in? Webb's discovery has challenged current perceptions of space and time, raising the possibility that our entire model of the cosmos may need a fundamental overhaul. Approximately 200 years ago, in a constellation far from Earth known as Apis, lies a particularly intriguing star called HD 14283. What makes this star so captivating isn't just its rate of travel, a blistering 4,483 kilometers per second, but the story hidden in its past. Around 1 billion years ago, during the early formation of our galaxy, the Milky Way collided with a much smaller one, and this star was among the survivors of that cosmic crash. Yet, what truly sets HD 14283 apart isn't its journey or speed. It was given the name Methuselah in honor of the legendary biblical figure said to have lived nearly 1,000 years. This star is regarded as one of the earliest ever observed. Initial calculations put its age at an astonishing 16 billion years. More recent estimates have refined this to about 14.46 billion years, with an uncertainty of 800 million years. This still places it older than the estimated universe's 13.8 billion year age, as calculated using data from the cosmic microwave background radiation. This apparent inconsistency has forced scientists to reconsider how we determine the ages of stars and the cosmos, driving deeper inquiry into these confounding astronomical riddles. To fully grasp this paradox, we must appreciate the difficulties in estimating the age of stars. Stars, like our Sun, remain fairly consistent in size and temperature over very long time spans, making it extremely difficult to determine their age. Astronomers must monitor tiny changes in a star's light and hue, and contrast them with complex models of stellar evolution. One of the most important methods is gyrochronology, which involves analyzing how fast a star spins. Just like a spinning top that slows down over time, stars gradually lose their rotation speed. By measuring this slowdown and comparing it to known-age stars, scientists can use mathematical models to estimate a star's age. Methuselah is unquestionably ancient and, by current measures, it is the oldest star we know of. Rather than focusing solely on whether it could be more than 2 billion years older than the universe, let's put 13.8 billion years in perspective. Imagine compressing all of cosmic history into a single year. The Big Bang happens at midnight on January 1st. Earth wouldn't appear until the final hours of December 31st, and the entire span of human civilization would be just the last few seconds of that fictitious year. Astronomers have determined the age of the universe by studying light from incredibly distant stars formed shortly after the Big Bang, and considering the influence of the redshift caused by the stretching of light as the universe expands. This data leads to the 13.8 billion year estimate, according to current calculations. However, a recent proposal made by the University of Ottawa suggests that this could ignore key aspects of the theory. The universe may actually be 26.7 billion years old. This bold idea was introduced by physicist Rajendra Gupta, who revisited a theory from 1929 by Swiss astronomer Fritz Zwicky and paired it with more recent insights. Gupta suggests that over enormous spans of time and distance, protons lose energy, a notion that runs counter to how we currently interpret redshift. Instead of attributing redshift solely to cosmic expansion, Gupta believes it might be a combination of factors. If true, this hybrid explanation could completely alter our understanding of how old the universe really is, potentially resolving several long-standing debates, many of which have come to light thanks to recent results from NASA's space program. The telescopes on which Gupta's theory is based revisit the old idea of light and introduce something referred to as evolutionary interaction constants, originally suggested by theoretical physicist Paul Dirac, who proposed that the character of cosmic forces may have changed over time. It's worth remembering that our ideas about the age of the universe have evolved significantly. Back in the 1920s, The universe's age estimated by Edwin Hubble was around 1 billion years. Over the decades, more accurate observations have raised that number to reflect the current consensus of 13.8 billion years. Whether we think of human history as a few seconds or milliseconds on the vast cosmic clock, there is no denying that the universe is incomprehensibly ancient, and its ongoing expansion constantly challenges our previous assumptions. Meanwhile, scientists are making fascinating insights into our own Milky Way. For example, recent data has demonstrated that stars on the outside of our galaxy move much more slowly than stars in other galaxies. One theory is that the Milky Way contains less dark matter than previously thought. Even though it is largely invisible, dark matter influences how gravity acts across the universe. Another possibility is that our understanding of how dark matter is spread across the entire universe is flawed. This mystery arises from information gathered by the European Space Agency's Gaia mission, which has charted nearly 2 billion stars in our galaxy. These findings have made us rethink the way stars behave, especially near the Milky Way's edges. The speed at which stars orbit is directly related to the total mass of the galaxy. Gravity's grip depends on how much both visible and invisible matter exist. A recent study utilizing Gaia's data suggests that the mass of the Milky Way, including gas, dust, stars, and dark matter, may be approximately 200,000 billion times the mass of our Sun, which is 5 times lower than previous estimates. This drastic reduction could imply a surprising conclusion: there may be less dark matter than previously thought. Calculating a galaxy's mass is extremely difficult. Complications and ambiguities in the satellite data or in the analytical models used could skew the results. As we assemble more precise data and develop better instruments, we'll keep trying. Keep an eye on these developments going forward. Future technological advances and space missions will likely illuminate many of these unresolved cosmic puzzles. The James Webb Space Telescope, with its unmatched power, is pushing scientific boundaries in ways never seen before. Its mission goes far beyond estimating the ages of stars or the universe itself. It's also revealing the inner workings of galaxies, the strange properties of dark matter, and the unseen forces shaping the cosmic evolution of the universe. The expansion of the universe remains a major mystery. But as new data become available, we might learn that our long-held assumptions were incorrect. A crucial question remains: do the physical laws on which we rely function the same way across all scales, locations, and ages of the universe? As our instruments become sharper and more capable, we may stumble upon discoveries that shake the foundations of contemporary science. Experts are starting to realize we are only scratching the surface when it comes to comprehending dark energy, dark matter, and the fundamental interactions that control the universe. For each new observation, from ancient stars to faraway galaxy remnants, we gain clues about how the universe functions. But these clues often produce more questions, pushing the edges of human knowledge ever outward. The possibility that stars might predate the universe, or that the cosmos itself is much older than we thought, prompts a complete revision of modern cosmology. It suggests we may need new theories, brand new physics, and perhaps a completely different way of looking through the layers of space and time. These developments don't just affect scientific models. They strike at the heart of philosophical questions about reality and our position within it. Discoveries could completely alter our perceptions and comprehension of existence itself. Through discussions, the true age of the universe continues to spark debate. It's becoming clearer that we're beginning a new era in cosmic exploration. The decades ahead may bring clarity to mysteries that have puzzled thinkers for thousands of years. Whether it's finding stars older than the known universe, or solving the riddles of dark matter and energy that continue to make up the cosmos, there are truths just waiting to be revealed. So stay connected for more updates on these incredible revelations and new theories. Keep your curiosity burning, because the future may uncover astonishing breakthroughs we can't yet imagine. If you're passionate about space science and want to stay informed, make sure to subscribe to our channel, hit that like button, and switch on the alert bell to ensure you never miss an important update as we journey deeper into the universe's depths.